Good morning, students. Most welcome again. We have come to the virtual classroom of Standard 9 to discuss the second part of your first chapter in your chemistry book, that is matter in our surroundings. I am sure you have come prepared from your first period and you have benefited from that period and done the exercises. Let us recap a little what we taught in the first period and where we left off and what we are going to study today. We are studying that matter according to the physical properties can be divided into three kinds of substances: solids, liquids and gases. And we in this chapter are going to explain what are the characteristics of solid, liquid and gas according to the kinetic theory of matter. What is kinetic theory of matter? It tells you mainly four things. Any kind of matter is made up of innumerable particles. Number two, these particles are always in motion. Number three, these particles have some space between them. And number four, in spite of having space between them, these particles have some force of attraction working between them. At this time we stopped on the first period. Now let us start from that part. Now before we go to the actual characteristics of solid, liquid and gas and what, why, what and how the kinetic theory explains these three states, let us learn two new words connected with this. Number one, let us learn this word rigid, and number two, fluid. All the substances in this world, they are either rigid or fluid. They either have the property of rigidity or they have the property of fluidity. So what is rigid? Rigid is that substance which is unbendable. You can break it, but you cannot bend it. You can chop it up in small pieces, but you can flex it. You cannot flex it. It is inflexible. So you understand anything solid, they have this quality, property of rigidity in them. And that's why they have a fixed shape, fixed volume, and if you keep it somewhere, you don't need a container particularly to keep it there. In the other hand, fluid is that thing, that kind of substances which flow very easily. You understand, if you take water and pour water on the surface of this table, it will flow. It will not stay at one place. So water is fluid. It has fluidity. In the same way, if we burn an incense stick, agarbatti, the smell will travel to all part of this room. We cannot keep the gas at one place, so gas is fluid also. Water is less fluid than gas, but both are fluid. And so we need a container to keep water, liquid, milk, kerosene, any kind of liquid substance, we need a container. And to keep gas at one place, we also need to keep a lidded container with a lid on it. It must be sealed. So these two qualities determine whether a substance can be called solid, liquid or gas. Now let us look at the kinetic theory, that 3 or 4 points I told you. You see, when we look at this theory from the point of view of whether it is fluid or rigid, we understand that in rigid substances, solid substances, the motion is in particles are very little. Motion in particle is more in liquid and the most in gas. Naturally, the space between the particles or rigid substances, solid substances, they are least, almost no space is between them. But in liquid, the space between the particles are more. And in gas, the space is as mass as possible. And interparticle force of cohesion, attraction, is most in solid. It is less in liquid and it is least in the gases, the force of attraction between the particles. So now let us, since we have understood up to this point, let us point out the characteristics of solids, liquids and gases. Solid substances, particles of solid substances, liquid substances and gaseous substances. Let us look at, draw a simple figure. Suppose we have an ice cube here. The particles of these solid substances have almost no space between them. So they are tightly packed. They are tightly packed. So in solid substances, there is a fixed form and fixed shape. They do not need any container to keep them at one place. They are very less compressible. We cannot press them much. Mostly we cannot press them at all, because there is no space between the particles. So how can we press them? If we keep the solid substances in any container, they will never fill up the whole container. If we keep the ice cube in a container, they will not fill up the whole container. These are the basic properties of solid substances. Because the force of attraction between the particles is the most, so the distance between the particles is the least. And that's why they have a fixed shape and fixed volume. Now if we make this ice cube into water, what will you see? That they must have the particle, the same number of particles. But now the distance between the particles have increased a little, because the force of attraction between the particles have become less. They are less attracted to each other. Naturally, they have become fluid. Now they have the same volume, but they do not have the fixed shape. They will take the shape of the container in which they are kept. Right? The liquids have a fixed volume, but they don't have a fixed shape. The interparticle force of attraction is less in liquid, so the distance between the particles are more, and that's why they act as fluid. They need a container to keep them inside it, but still, they also don't fill up the whole container. They also don't fill up the whole container. Now let's go to the gas. In the gas the force of attraction between the particles is the least in a gaseous substance. So they are always running away from each other. They are increasing the distance between them. So gaseous substances are more fluid than the liquid. They need a sealed container, leaded container to keep them inside. And force of attraction. So these are the basic characteristics. If you look at it, solid could not be compressed at all in fact, because there is no space between the particles. But since the liquids have some spaces between them, you can compress it a little bit. More than the solid, but not much. But in gas, there is so much space between these gas particles. If you want and put a pressure on them, you can compress it into a very little space. Let us look at a slide of an experiment to explain this pressure, how pressure works on a solid, liquid and gas. Look at the picture. It is an experiment that we can do with 3 glass syringes, injection syringes, that is 100 milliliters say. In the first syringe, we put some common salt, which is solid. In the second series, we fill with water. And in the third series, we do not put anything, that is, it has already air in it, that is gas. Now we try to push down the piston. You understand what will happen. In case of the solid, the salt, the piston will not go down much. In the case of water, liquid, it will go down a little more. And in case of the syringe with air in it, the piston will go down almost to the full length. It shows that pressure applied to solid, liquid and gas acts differently because solid is almost not compressible. It does not have any space between the particles. Liquid have more space, so it is a little more compressible, and gas can be compressed very much into a very small space. With this in mind, let us move to the next slide. That is, we have told you that 2 factors which decide whether a given substance, it would be in a solid or liquid or gaseous state. These 2 factors, temperature and pressure, entirely these 2 factors determine whether a certain substance will be in the solid, liquid or in the gaseous state. And we can change the physical state of matter through 2 processes. Number 1, by changing the temperature, and number 2, by changing the pressure. So, since we have already understood the pressure part, let us go to a more important part, because the effect of pressure on the substance is solid, liquid and gas. It will be discussed more in detail in the upper classes, in the higher secondary classes. But now we deal with another very important factor, that is heat. The effect of heat and effect of pressure that helps change a substance from solid to liquid state and liquid to gaseous state. The part of pressure we have understood, let us keep it there, whatever we have learned. But heat, the effect of heat on. Now this is a nice tube idea. It is solid, it has a fixed rate and firm, fixed volume. It needs a container don't need a container, but we can keep it in the container, it will fill up only the lower part of the container. It cannot be waste. But if we build a fire and provide heat energy to these particles, the particles, they get more energized. Heat energy gets converted into kinetic energy. And the particles, they start to move apart because now they are more energetic. They are imbibed with the kinetic energy. What will happen? They will try to move away from each other. The motion, speed of motion will increase. Gradually the space between them will increase. They will move apart from each other. So there will one stage come, this solid substance will become fluid, liquid, because now the heat energy converted to kinetic energy have made the movement of the particles more fast. And if we go on keeping heating this water, so one point will come when these particles with more kinetic energy, faster motion in them and lesser force of attraction between them, more distance between them, they will go away, fly away from each other in the form of vapor unless you keep a lid on the container. Very soon the entire water will vaporize, entire liquid will vaporize in gas. So this is the effect of heat, of the heat energy in the process of changing of state. Now let us look at the three stages and name the processes involved.
This is a triangle of how heat affects the change of state. You see, if we add heat, it will be shown by the arrow. If we add heat solid, it melts and it becomes liquid. And if we add more heat to the liquid, it boils or evaporates into gas. And again, if we take away heat, if we cool down a gas, it's a reverse process, condensation, it becomes liquid again. And again, if we cool down the liquid, it freezes into solid. Some solids are there, we'll talk about it later, which directly on heating becomes gas and on cooling from gas to become solid. This process is called sublimation. Let's start with the first process. The process in which a solid substance changes into a liquid on heating. You add heat energy to a solid substance and it changes into a liquid. This process is called melting, or we also call it fusion. The temperature at which a solid substance melts and changes into a liquid at atmospheric pressure. The pressure is steady, pressure is normal and steady. Only the temperature increases and the solid substance melts, changes into a liquid at atmospheric pressure. This point of temperature is called the melting point of that substance. Now the second process, we go on adding heat to the liquid. The process in which a liquid substance changes into a gas and very rapidly. It happens more rapidly than melting. On heating, the liquid changes to gas very rapidly. This process is called boiling. And the temperature at which a liquid boils and changes rapidly into a gas when the pressure is normal at atmospheric pressure, that point of temperature is called the boiling point of the liquid. Now the reverse process. The process of changing a gas or vapor to a liquid. How it will be done? It will be done by cooling, opposite of heating. The process of changing a gas or vapor to a liquid by cooling is called condensation. Condensation, you understand, is the reverse process of boiling or vaporization. The process of changing a liquid into a solid by cooling is called freezing. Freezing means solidification, to make something solid, solidify. Freezing is the reverse process of melting. And now we talk about a certain phenomenon. Some of the substances are there that on heating, it skips the liquid state. It becomes vapor directly. And in the reverse process, when it is cooled down, the vapor becomes solid. This process is called sublimation. The changing of a solid directly into vapor or gas on heating is called sublimation. And the changing of vapor or gas, the reverse process, directly into solid by cooling is also called sublimation. Some common substances which we see in daily life that sublimate are ammonium chloride, iodine, camphor, naphthalene, and anthracene. You have seen all these substances in your daily life at home for different uses.
So, my dear students, take these 2 periods on your first chapter of chemistry as an introductory period. Don't think that only listening, by listening and watching this video, you will learn science. Go to the books. Read the books thoroughly after listening to this, watching this video and listening to it. Go through it line by line, word by word. Because the more you will read, it will not only give you the power, command over the actual subject matter, but it will help you in another way. Your English language, command over the writing, speaking, reading. The more you will read different kinds of English. English cannot be learned only through literature, because we don't talk in the language of literature in everyday life. We must be exposed. You must expose yourselves to different kinds of English. The scientific English, the English used in the social sciences. So, reading the books word by word is a must. Keep it in your mind. And do the exercises that we will provide you with this video. Do it separately. Do some exercises. Go to YouTube, internet to have more explanation of the terms I have introduced in this lecture. And I am sure you will get benefited even in this time. Stay home and stay safe. We will meet again very soon in the actual classroom. Till then, goodbye and thank you.